what we have discussed is, let's say, how to find out the amplitude ratio and phase angle for variety of systems. Like for variety of systems, how do you find out? So how do you find out is, so put S is equal to j omega, transfer into, let's say, a plus ib form. Then root of a square plus b square is amplitude ratio. Tan inverse of b by a is your phase angle. So what is your amplitude ratio is root of a square plus b square. Phase angle is tan inverse of b by a. So for any kind of systems, you can do this. So clear. So what is a and b is, suppose if I have, let's say, kp by tau s plus 1, just push is equal to s equal to j omega, transfer into a plus ib form. So if this is in the denominator, then you have to normalize it. Suppose if this is in the numerator, then no need to normalize it. Okay, so we have done it for multiple functions systems yesterday. Then similarly, we have defined, let's say, what is transportation lag, e power minus tau ds. Then what is the amplitude ratio? Here is 1. What is the phase angle is minus tau d into omega, or minus 57.32 into tau d omega. What is minus 57.32 is nothing but 180 divided by pi. So clear. So that is the point. Then, so let's solve one problem. Let's solve one problem. So write this problem for a system given below. For a system so x is equal to 2 sin omega t. So what is equal to 2. That means tau 1 is equal to 1. So the system is forced by a sine input, which is x equal to sin omega t. So first question is, if the response lags behind, if the response y, basically, if the response y lags behind the input by 45 degrees, then what is W? So what is second question is, for the same input, the amplitude of Z is. What is meant by lags behind? That means phase angle is negative. Phase angle is minus 45. Phase lead or phase lag? Phase lag means minus, negative sign. So what does that mean is phase angle is equal to minus 45. Phase angle of minus 45, which gives phase lag is equal to 45. So both are equal. Lag itself will cover the minus sign. So are you getting? See, phase lag of 45 means phase angle of minus 45. Lag itself is minus. So basically you have two systems in series, 1 by tau 1 s plus 1. So the input is x, the output is y. Then this goes to another system, 1 by tau 2 s plus 1. The output response is z. When x is equal to 2 sine omega t, then what is the y? So the phase angle between x and y is minus 45. So that is phi of y to x is nothing but minus 45. So what is phase angle of minus 40? Y to x is a single system. So that is tan inverse of minus tau 1 omega is equal to minus 45. What is tau 1? 1. So what is tan inverse of minus omega is equal to minus 45. So what is omega is equal to 40 for tan of 45, which is 1. So what is omega is basically radians. 1 radian per minute. This is what is actually omega. Suppose in the question, if he gives answers in the time of, let's say, cycles per minute, then what is cycles? Radian frequency can be cycles also. What is cycles is W is equal to 2 pi f. So this is what is difference between f and omega is both are frequencies. F talks about cycles per minute. W talks about radians per minute. Because every cycle has a angle of 2 pi. So every cycle makes 2 pi radians. So then what is radians frequency is W by 2 pi. So that is 1 by 2 pi. will be same because that is input. No, value of W will be same in both because that is input. Input wave frequency is 2 pi f. So did everybody get W equal to? So what is the second one? So what is the amplitude of Z? So for that one, we will write what is the amplitude ratio of Z by X, which is nothing but 1 by root of 1 plus tau 1 square omega square 1 by root of 1 plus tau 2 square omega square. What is amplitude ratio of Z by X can be written as amplitude of Z by amplitude of X. So what is this ratio? 1 by root of 1 plus, what is tau 1? 1. What is omega? 1. So what is tau 2 is 2. 1 by root 10. So AZ by AX is 1 by root 10. What is AZ? AX by root 10. So this is 2 by root 10. So this is nothing but What is amplitude of Z is 2 by root 10. See here, there is a chance of mistake. Somebody will answer amplitude of Z as amplitude ratio. Amplitude ratio is different. Amplitude of Z is different. Clear? So another problem. So write this problem. The time constant of a unity gain first order system with time delay is 5 minutes. If the phase lag at a frequency of is 60 degrees, so that time or transportation lag both are same. This is a previous gate question. That time or transportation lag both are same. So this is the previous gate question. Very good question. First thing is you understand the problem. It is a first order system with the time delay. So that means it is two systems in series. So time delay means e power minus tau ds. What is first order system? Kp by tau s plus 1. So this is the transfer function. Now rest of all the values are given. Then you need to find out what is the dead time here. What is the transfer function which is given? Given is equal to 1, and then time constant is equal to 5 plus 1. 1 by 5 plus 1. Clear? So then what is the equation? Phase angle of e power minus tau ds plus phase angle of 1 by 5s plus 1, which is equal to, is, if the phase lag he has given, lag means don't take it as directly 60, it is minus 60. What is phase angle of e power minus tau ds? See here it is important. Phase angle of e power minus tau ds plus phase angle of 1 by 5s plus 1, which is equal to minus 60. Now, should you decide, will you solve this problem in degrees or radians? Let's assume that you want to solve in radians. Then what happens is minus tau d into omega plus tan inverse of minus 5 into omega, which is equal to minus pi by 3. This is how you solve. What is omega given at a radian, at a frequency of, what is the frequency which is given? 0.2 radians per minute. So that is minus tau d into this is, let's say, 0.2 minus of tan inverse of minus 5 into 0.2, which is equal to minus pi by 3. So all the minus will cancel. What is tan inverse of 45? Tan inverse of 1, pi by 4. Tau d into 0.2 plus this is pi by 4, which is equal to pi by 3. So tau d into 0.2, which is equal to pi by 3 minus pi by 4, which is pi by 12. So what is tau d is 5 pi by 12. This is if you want to solve this problem in radians. So how many, this minus, so this will be plus. This minus had come out, has become minus, so that is why minus is cancelled on both. Now if you want to solve this in degrees, then what happens is minus 57.32 tau d into 0.2 minus plus tan inverse of minus 5 into omega r 0.2, which is equal to minus 60. So minus 57.32 tau d into 0.2 minus 45 is equal to minus 60. So if you solve this equation, 57.32 into 0.2 into tau d plus 45 is equal to 60. So what is tau d? So you are going to get the same answer. What is the answer that you are getting? 60 minus 45, 15. 15 by 57.32. 1 point. It will not be 1.3, no? Into 0.2. So what is the answer that you are getting? So basically 75 by 50.32. What is this 57.32? Is a conversion from degrees to radians. That is nothing but 180 divided by pi, which is 57.32. I think my pencil has some problem, so I'll stop the class here. I think this is not writing properly, so I need to change the needed. So I think I'll not take another, let's say, half an hour class. So it becomes a little difficult for me to write. So this pencil is not working well. We will continue. So after this problem, we'll continue tomorrow. So we'll start tomorrow. We will start with Border plots. So that will be, I think, another 2 classes or 3 classes for the frequency response, and 3 classes for the chapter 2 and chapter 5. So another 7-8 classes will close the entire process dynamics. So do you have any doubts till now? So I think today we have solved only 2 problems. So tomorrow mostly same timings, or let's say little early. So basically lag means negative. Lag indicates it is negative. Phase lag and phase lead. Phase lead indicates positive. Phase lag indicates negative. No, we can't say yes. In the previous table, we can say that is stable. And moreover, you don't need the frequency response to say that whether it's stable or not. Look at the transfer functions. What is this transfer function? 1 by s plus 1, 1 by 2s plus 1. What is the roots? One root will be minus 1, another root will be minus 1 by 2. Both are sitting on the right side of the imaginary axis. So that means this system is stable. I think I'll close it here. If you have any doubts, I will take the doubts. So tomorrow we'll start border plots. Board plots, which is actually important for gate point of view. If you have any doubts, I'll take your doubts.